Hello, this is Scott Sturgill back with you again. This time to discuss the dynamics of the nutrient phosphorus and its interactions in the soil. Phosphorus, like all soil nutrients, moves through a series of chemical and biological cycles from the soil to the plant to animal. These interactions include additions to the soil, removals from the soil, and transformations within the soil itself. Phosphorus is naturally added to the soil through the weathering and breakdown of soil minerals. The latter is a very slow process and would not meet the nutrient demands of most agricultural crops. Soil organic matter also releases phosphorus as it breaks down over time. Of course, the addition of phosphorus-containing commercial fertilizers adds phosphorus to the soil, as does the land application of manure and other soil amendments such as biosolids. The return of crop and plant residues to the soil is also a source of phosphorus. A minor amount of phosphorus may also be delivered to soil via rainfall. Phosphorus is removed from the soil through several mechanisms. Crop uptake of phosphorus and the subsequent harvest of the crop removes phosphorus from the soil. Phosphorus can be lost from the soil through runoff, which is the overland flow of water that has not infiltrated into the soil, and erosion, which is the removal of soil from a field or a landscape. Controlling runoff and erosion losses are our biggest challenges in phosphorus management. In some areas, such as on very sandy soils, or soils with high organic matter content, or soils extremely high or saturated with phosphorus, phosphorus can move with water as it percolates down through the soil, a process called leaching. If the phosphorus leaches far enough, it could enter groundwater. If this groundwater recharges lakes and/or streams, groundwater flow could contribute phosphorus to surface water bodies. It should be noted that phosphorus leaching is relatively rare due to the ability for most soils to tightly hold phosphorus, which is a subject we'll talk about in the next slide. Phosphorus can undergo a series of very rapid and very slow transformations in the soil. The majority of soil phosphorus is located in the topsoil and is in two forms, or pools, if you will, an organic pool of phosphorus and an inorganic pool of phosphorus. The availabilities of both pools of phosphorus are controlled by soil properties and environmental conditions. Organic phosphorus is stored in the soil's organic matter. Organic phosphorus is not in a form that is usable to plants. Similar to nitrogen, organic phosphorus must be converted by soil microorganisms in order for it to be transformed into an inorganic, plant-available form. This process is called mineralization. Inorganic, or mineral phosphorus, is the plant-available form of phosphorus. Plant roots absorb inorganic, soluble, or dissolved phosphorus from the soil solution. The concentration of plant-available soluble phosphorus in a fertile soil is very low, even though soils typically contain very high levels of total phosphorus, which is the amount of inorganic and organic phosphorus. The vast majority of soil phosphorus is strongly bound and held or fixed to clay particles and soil minerals and is unavailable for plant use. Practically all soluble or dissolved plant-available phosphorus from manure or fertilizer applications is rapidly converted to soil-bound phosphorus shortly after application. As soluble P is depleted in the soil through plant uptake, additional phosphorus is released from clay particles and soil minerals into the soil solution and available for plant uptake. This table shows the form and typical concentrations of phosphorus in soil. You can see that only a small amount, about 2 to 5% of the total soil phosphorus content is potentially plant available, as measured with a soil test. Only a very small portion of a typical soil's phosphorus content is in that dissolved, readily plant available form. So to summarize our discussion on the behavior of phosphorus in soil, 1. Soils usually contain large amounts of phosphorus. 2. Most soil phosphorus is fixed, meaning it is tightly bound to soil particles and unavailable to plants. 3. Available phosphorus from fertilizer, manures, etc. is quickly and strongly bound to soil particles such as clays, organic matter, and minerals. And 4. There is typically very little leaching of soil phosphorus. So despite the rapid tie-up of phosphorus in soils, available phosphorus levels in Wisconsin cropland soils have been steadily increasing over time, particularly on our livestock farms. The following presentations on agricultural management for phosphorus will discuss options for decreasing this trend and minimizing the impacts of elevated soil phosphorus on water quality.